Hello there everyone, welcome to video number 165. This one is on surface area of solids, and the keywords I've got for you are surface area, prism, solid, squared units and cross section. So the surface area is the area of the entire object. It could be all the faces added together, all the areas of all the faces added together, or it could just be the surface area of whatever the solid is. A prism is a specific type of solid, specific type of 3D shape. It's one that's got a constant cross-sectional area, and I've done a video on those, so please watch that to understand a little bit further in the world of volume, that is. Solids are just 3D shapes or objects. Squared units are the units in which we give our answers to area questions, and cross-section is the front face or the bottom face of the shape that's extended all the way through. Okay. Now, to calculate the surface area of a 3D object, you must know the area formula really well. To calculate the area of a 2D, what you need to do is to calculate the area of surface area of a particular prism. Calculate the area of the 2D shapes that make up the 3D object. Okay. If the object isn't a prism, then you'll be given a formula to use. So if you've got the prism, add the areas together for the prism surface area, the area of all the 2D faces. If you haven't got that, then you've got a formula and you just substitute into the formula to get the surface area of that particular object. And that would be for a cone, a sphere or a cylinder at GCSE. And yeah, so we get given those. The cylinder is one that we have to know ourselves. We don't get given the formula for that. That's something we have to work out for ourselves. And I'll show you that a little bit later on. Now, question number one is a prism. It's a triangular prism. We've got to calculate the surface area of the prism. So it's a case of working out the area of all the faces added together. I'm going to start with the triangles. So the area of the triangles equal, and do both of them at the same time, because what you would normally do is 4 multiplied by 6 and half it. Well, you've got two of them, so there's no point in halving it. So just do 4 times 6. Okay, and you can get 24 centimeters squared. All right, that is always going to work with a triangular prism. All right, you're always going to be able to do that. It's whatever this dimension is multiplied by this dimension, because there are two of them. Halving and then times by 2 is pointless. Right, so we've got shapes 1 and 2 done there. Okay, there's the two triangles. Let's do shapes 3 and 4. Okay, let's say that's this rectangle and this rectangle. They are the same as each other. So the area of rectangles equals, now there is a third rectangle, it's on the base, but we're not going to worry about that one at the moment. So 3 and 4 is going to be 13 times 5, right, which is 65, and then 13 times 5, which is 65, right? So 65 plus 65 is 130. So 130 centimeters squared for the area of these two rectangles, and the area of the final rectangle, I'm going to call it base rectangle, is 6 times by 13. So 6 times 13 is what's 10 times 6? 60, and 3 times 6 is 18, so 78 centimeters squared. Now what we've got to do is add these answers together to get the surface area of the entire object, because there are 5 faces. We've got 5 faces. We've got the 2 triangles, we've got the 2 side rectangles, and we've got the base rectangle. Okay, you don't have to necessarily do it that way, but as long as you've got all the faces, you can add them together. It's going to be 78 plus 130 plus 24. Okay, that's 5 faces. 232 centimeters squared is what the answer would be. 232 centimeters squared. All right, I hope that makes sense. And that will work for any different type of prism. All right, work out the area of each of the faces and then add them together to get the total surface area. Now, in question number 2, we've got 2 objects that we have formulas for. We get given these formulas, and you always will get given these formulas within the exam question itself. All right, it used to be that formulas were at the beginning of the paper, not anymore. You're going to get this formula within the question, so it's quite nice, right? So we're going to use the formula to calculate the surface area of solids A and B, A being a cone, right? And this is the formula that works out, okay? Now, pi times radius squared is the area of the circle on the bottom. plus pi times the radius times by the slant height is what that means. Okay, that L represents the slant height, so the slant height in this question is 12. Okay, and that's basically all you need to know, and the rest of it is just substitution. All right, so surface area, I'm just going to call it SA, equals pi multiplied by 3 squared. I'll just pop that in brackets there like that, and then plus pi multiplied by 3 times 12. Okay, because we've got two separate calculations that we're doing there. If we want to do them one at a time, we then add them together to get the answer. Okay, so the surface area of that is going to be, let's get our calculator in. Most of the time you get calculators for these things. So let's just put it in brackets like that, so we know we're calculating it all nice and correct. No mistakes. Because this is a bit of an old school calculator, it does kind of mess things up sometimes. So pi multiplied by 3 squared, and then we'll add on the pi multiplied by, oops, I didn't mean to press that. No, I did. Pi multiplied by 3 times 12. Okay, and then that's going to give us a 45 pi centimeters squared, or it's going to give us, if we want it as a decimal, we had to have it as a decimal and round it, 141.37, I'm going to round it to centimeters squared. That's the 2 decimal places. You could obviously round it to whatever degree of accuracy you wanted to or had to. Now, the second question, the only thing we've got to be careful with here in the second question is that we don't use the diameter. All right, we want the radius, so 4 times pi times radius squared is how that reads for the surface area of a sphere, and the radius is 9 centimeters. Okay, the distance from the middle to the edge, it's the same as a circle, right? So if we substitute that in, so surface area equals 4 times by pi times by 9 squared, we're going to get our surface area of 4 times by pi times by 9 squared, so that's going to be 81 there, isn't it? 324 pi, and that is in centimeters squared. Now again, we could have our decimal answer if we wanted it of 1017 point something 88, I think that will round to, yes, 0.88 to 2 decimal places. Alright, and there you go. So just be careful when you substitute it in, but otherwise it's pretty simple, especially if you've got a calculator. Right, now what I've included in question number 3 is a very, very difficult question. I wouldn't suggest that this is a grade 5 question. I suggest this is probably more grade 7. However, and this did used to be an A grade maths topic in its own right, never used to be on a foundation paper. But yeah, this one is a very difficult question. However, the beginning of it is important that you understand, because a cylinder is something you need to know how to work out the surface area of, and I'm going to show you how you can do that at the beginning. If you don't get anything else after that, that's not too bad if you're doing foundation. Obviously, if you're doing higher maths, it would be a good idea to understand it a bit better. Just notice that radius is spelled incorrectly. Let's change that. So, right, a cylinder has a radius of x and a height of y. Okay, a sphere has a radius of x. They have an equal surface area, and we've got to show that x equals y. X is the same thing as y. All right. So basically, let's start with the surface area for a cylinder. All right. So cylinder surface area. I'm just put SA cylinder equals. Well, it's easier to understand using a net. So here is a net of a cylinder. One way of drawing a net for a cylinder. Now we've got a circle which we can find the area of. Another circle which is exactly the same, which we can find the area of, and then we've got a rectangle in the middle. All right. Now this, it will be the height, whatever this measurement here is. Okay, that's our height. That could be changeable, right? But this is always going to be able to be worked out doing pi times diameter, because this is the same length as the circle's circumference, because the circle needs to roll all the way, the rectangle needs to roll all the way around the circumference of the circle. All right, so that measurement there is always going to be able to be calculated using pi times diameter. Right, remember pi d is the same as 2 pi r, okay, or 2r pi, 2 lots of the radius, okay. So we're going to use that there, right, in this instance, because diameter is 2 lots of r, right, pi 2r, r 2 pi, doesn't matter what order you do that in, right. And we've got the two areas of the circle here. So if we're going to do this times this, because it's a rectangle, right, h times by pi times by diameter, I'll write it all out, okay. So we're going to have pi times by the radius squared, right, plus pi times by the radius squared, because there's two circles that are exactly the same, plus pi times by diameter times by height, pi diameter height, okay. Now let's change these things for the things that I say we need to change them for, right? And a sphere is a bit easier here to do the substitution into with the, because what we're actually doing, we're not substituting the letters for numbers, we're substituting the letters for letters, right? Now, like I said, that's an important thing that you understand at foundation. The rest of this is probably definitely just higher stuff, okay? So pi r squared becomes pi x squared, because I'm changing that r for an x, right? And then I'm adding on the pi x squared, okay, plus pi, and then I'm going to change the 2, I'm going to write that as 2r pi, or pi 2r, pi multiplied by 2r for the diameter, all right, multiplied by the height, which is y, all right. So I didn't need to put those multiplication symbols in there, but I'm just showing you that that is kind of what it means, right? So if you've got pi x squared plus pi x squared, you've actually got 2 pi x squareds, right? Then you're adding on the 2 pi r y, right? So r being x, I should have changed that to an x, shouldn't I? My bad. Going to say, because I changed those to x's at this stage, so I'm going to change that r to an x at this stage. There you go, right? So that's 2 pi x y, right? So plus, just put that in brackets like that, and then this in brackets like this, 2 pi x y, okay? Now that's kind of as simple as we can make it at the moment without factorizing, right? But we can actually factorize this because both of these terms here have got a 2 pi and an x in, right? So we can take a factor of 2 pi and x out of both of those and then open up our bracket and put an x plus y. That is factorized, okay? And that's as simple as we can make it for the expression of the surface area of the cylinder, okay? Now the sphere, surface area of the sphere, is equal to, is much easier, and you'd be given this as well in the question, 4 pi r squared. You'd be given that, right? It's 4 times by pi times by x squared. I've just changed the r for an x, okay? So we know they've got an equal surface area, so we can make this equal to this, right? So 2 pi x and then brackets x plus y is equal to 4 pi x squared, right? Now what this becomes is a simplifying algebraic fractions question, right? We've got x plus y on this side equals 4 pi x squared divided by 2 pi x, okay? Now 4 divided by 2 is 2, pi divided by pi is what cancels, it's 1, and x squared divided by x is x. So what we've got left on that side, and I'll have to come over here a little bit and do it, is x plus y, just show you going down here, x plus y is equal to 4 divided by 2, which is 2, pi divided by pi, which is 1, so no pi's there, just times by 1, that doesn't do anything to the number 2. And then x divided by, or x squared divided by x is x. So 2x is what we've got left on that side, and then what we end up with is y equals, take x away from both sides, x. Okay, which is the same thing as x equals y. So therefore, x equals y. All right. I told you that was a very tricky problem, and I was not lying. It is a very, very tricky problem. It is not foundation maths, because you've got this simplifying of algebraic fractions happening here. All right, which is a grade 7 skill in its own right. So if you've understood that one, I really do think you've done very, very well. But in essence, it's pretty simple process, isn't it? Surface area of prisms is nice and easy. Surface area of solids, if you've got the formula, you just substitute into them. And yeah, thanks for sticking with me on this one. I appreciate it. If you have done that, and please click the link in the description to practice, do a bit more, and take care of yourselves, look after one another. I'll see you in the next one. Bye-bye.